Alright, if you ever hear the word function in mathematics, it's basically taking a number and it's putting it through the function. It's like a machine, putting it into the machine, putting it into the function, and it's spitting out another number. So, for example, let's say we had an ordered pair 1, 5. And down here we had our function. This is like our machine here. Let's say we took a 1 and we put it inside the function. The function does its thing, and it spits out a 5. So you can think of functions taking in an input. For this example, it'd be 1, and it's then putting out an output. In this case, it's 5. Not all relations are functions. So you might ask yourself, is this relation a function? How do I know? Well, a function has exactly one y value for each x value. So for every x value, you only get one y value. Let's look at this example here. So we've got a relation here. We've got 1, 1, 2, 3, and negative 1, 2. So if we put our numbers through our function, let's say we had function of our number 1. So what I'll do is I know I want 1, so I go up to here and I find 1. Here's 1 right here, and I know that's going to equal 1. All right, let's do another one. Let's say we had 2. We put 2 into our function. Well, I go up here and I look for number 2, and I say, well, okay, I know 2 has to equal 3. All right, let's do our last one. Let's say I had put negative 1 into our function. Well, up here, negative 1, that equals 2. So is this a function? Is this relation a function? Yes, this relation is a function because for each of these x values, we got one y value. For each input, we only had one output. Okay, let's do an example of something that's not a function. So let's look at this relation here. Let's put our numbers here through our function. So let's say we had f of 1. Alright, well, let me go up here and I see f of 1 equals 5. But also up here, I have another one here. F of 1 can also equal 7. So I don't know which output is going to come in, because if I plug in 1, I have two options. I have the option of 5 and the option of 7. So this is creating some confusion. And when we have this confusion, when we have more than one y value for the same x value, here we had 5 and 7 for the same x value of 1, that's how you know you do not have a function. So this is not a function. Alright, so we've been looking at functions as a set of ordered pairs. Let's look at the function as if we graphed that set of ordered pairs. So let's say we had our coordinate plane here, we had our x-axis, a y-axis, and let's say, for example, we graphed a line here. Now, if we wanted to determine if this represented a function, what we need to do is we need to go across our x values and see if we only have one y value. So over here, I can go down and my y value would be, let's say, for example, I had negative 4 and this was negative 2. So I go over to my x value of negative 4, I can go down to negative 2, and I have one y value there, and that would be negative 4, negative 2. I could also come over, let's say over here, I had 3, 1. I can go to the right, I have 3 is my x value, 1 is my y value, so I have 3, 1. An easy way to test all the points, because we have an infinite amount of points on this line here, would be something called the vertical line test. Basically, you start at the top and you start drawing vertical lines, and if your vertical line only crosses one point on the graph, you know it's a function, because that would be there's only one y value. So if I went vertical line here, here's 1 point, no others. Vertical line test here, 1 point, no others. And I can keep going doing the vertical line test the whole way across, and I'd see that, yes, this is a function. All right, let's look at this graph as a circle. Do you think that this circle, this graph, this equation that represents a circle, is a function? Well, since I have a graph, we can start by doing our vertical line test. So if I start here and I go down, well, I've got a y value here. And then if I continue going down that same line, I get to another y value here. So since I have, for one vertical line, I have two different y values, that would be for this x value right here, I can either go up to this point or I can go down to this point. We don't know. There's that confusion that we represented earlier. So if the vertical line test fails, if there's more than one y point on any given line, then it's not a function. So this would be not a function.